In this video, we're going to do a quick demo of a Halix program using the assembly language. So you see on your screen here a program called add3, and we're going to add three integers. We're going to look at the pseudocode because this is how we could have done this pretty much in C++. Notice that we need three variables, three input variables. We need a variable for sum. So we need a total of four variables, A, B, C, and sum. So in the Halix assembly language, we create a data section that goes above the code. In the data section, we begin by saying how much space do we need. We ask for five variables, space for five variables. We actually are using four. So for variable A, we will initialize it to 0, and this just show you how. When you specify a value, you must put an equal sign immediately followed by a value. Please note that there are two columns here. There's a column over here on the left where we put names for things. There's a column here which is where we put instructions or directives. These dot commands are like assembler directives, pretty much like a pound is in C++, a line that starts with a pound. Okay, so this says I need to allocate 5 spaces. I need one space that will be called A, initialize it, B, C, and sum. Do not initialize those. So get used to doing that. This is how we handle variables. In Halix, all variables are integers. There is no float. Now, let's look at the code. The code is marked. The beginning of the code is marked with the directive dot begin, and the end of the code, the directive dot end. Okay? Now, it makes sense to put some vertical spacing so that you can get a sense of what you're accomplishing. You may, and you inside the begin and end, if you put comments, they must go in this third field to the right of the instruction. For neatness sake, align them so it's pretty easy to follow what's going on. So clearly, to read the three inputs, which is what I want to do here, I just use read instructions. Is anything else required? No, because the read instruction will read a value and store it directly into the variable. All right. Next thing we are going to do is to set the sum to 0. Notice that the variable sum was not initialized, therefore the program must initialize it to 0. And how do we do that? How do we put values into a data memory location? And it's either when we initialize it here, or when we read a value in, or when we store what's in the accumulator. So in this case, we need to store a 0, so we put a 0 in the accumulator, which is clear. Okay? And notice that we can also say set I space equal 0. That will be the same as the clear instruction. And then we finally store a sum here. So at this point, we have a sum. Now we can add all these values. How do we do that? Every time we add, a result is put in the accumulator so that we can really add the three numbers to whatever we begin with in the accumulator. In this case, we load sum, which should have been a 0, and we add three values to them, A, B, and C. At the end of that, we want to store the result into the variable sum. So we do the store. And finally, we output the results in the required order. Notice that I have the halt instruction. I have a label on this instruction. There's a name followed by a colon. I'm not using the label now, but I'm reminding you that this is really the last thing in the program. Now, I have shown you how to assemble the program. In your case, you will say hasm.crun. Over on the Unix side, there's two different steps for doing that, and we're just going to do it. And this is going to be add3.how. For some reason, this thing is much slower over here than it is for you, fortunately. What is the assembler going to do? It's going to produce the .hlx file, or the executable file, which we can now run. So when this finishes, we're going to take a look at what we have. So when we finish it, we have a listing file, HLL file. So it kind of combines the source file .hal and the object file HLX. So the first part you can read, and it should match pretty much what you wrote. Notice over here to the left we have the translation. We have the translation of your source file. The top part, first 4 lines, is the data memory. So that variable A is address 00, sum is address 03. Between the begin and the end, we have the instruction memory, and the object code is over here. Here's the object code. This column going all the way down. All right, and this is shown here. Now we can run it. add3.hlx, and when we run it, we got to add 3 values. So I'm going to put 17. 18, that makes 35, and I'm going to say minus 10, so it should be 25 as the output. Okay, I printed the numbers out in the reverse order I read them. I read 17, 18, minus 10. I output them in the reverse order. Notice that when you run the program, it produces a trace file, and it's this trace file that will tell you which instructions get executed, what the result of executing them is, and so forth. All right, we're going to stop right here.